Now we're moving on to sensation and perception and states of consciousness, although we've done a section reading on sensation and perception, we'll cover it again. First and foremost, I do want to briefly go over the introduction. Our sensory systems provide vital information about our surroundings, helping us navigate and interact with the world. Sensation refers to the process of receiving stimuli, while perception is how we interpret stimuli. Explore the reception and processing of sensory information, focusing on the physical properties of light and sound, the major sensory systems, and the Gestalt theory of perception. Sensation versus perception. Sensation occurs when sensory receptors detect stimuli, while perception involves organizing and interpreting these sensations. Sensory systems have absolute thresholds, minimum stimulus needed for detection, and difference thresholds, which are minimum difference needed to notice a change. Sensory adaptation, selective attention, and signal detection theory help explain what we perceive. Our perceptions are also influenced by factors such as our beliefs, our values, our culture, and our life experiences. And again, perception involves organizing and interpreting sensations. Sensory systems have absolute thresholds, which are minimum stimulus needed for detection, and difference thresholds, minimum difference needed to notice a change. Concerning waves and wavelengths, light and sound are both characterized by waveforms with properties like amplitude, wavelength, and timbre. Wavelength and frequency are inversely related. Longer waves have lower frequencies, and shorter waves have higher frequencies. In vision, for example, wavelength determines color and amplitude affects brightness. In hearing, frequency determines pitch and amplitude affects loudness. Concerning vision, light enters the eye through the cornea and pupil, with the lens focusing it onto the fovea in the retina of the eye. Cones in the fovea provide sharp vision in bright light, while rods across the retina function best in dim light. Visual information exits via the optic nerve, crosses at the optic chiasm, and is processed in the occipital lobe of the brain. Color perception is explained by the trichromatic theory, the three cone type sensitive to different wavelengths, and the opponent process theory, color processed in opposing pairs. Depth perception relies on both monocular and binocular cues. Concerning hearing, sound waves enter the auditory canal, causing the eardrum to vibrate and move the ossicles in the ear, which press against the cochlea's oval window. This movement creates fluid waves in the cochlea, stimulating hair cells in the basilar membrane to send neural impulses via the auditory nerve. Pitch perception depends on hair cell firing rates and, of course, their location on the basilar membrane. Sound localization uses monaural and binaural cues. Deafness can be congenital or acquired due to age, genetics, or the environment, and conductive hearing loss results from eardrum or ossicle tissue issues, while sensory neural hearing loss involves auditory nerve signal transmission failure. There are other senses like taste and smell. They are chemical senses that use receptors in the tongue and the nose to bind with molecules, transmitting information to the brain. Touch, temperature, and pain are sensed through receptors and nerve endings in the skin and body tissues. The vestibular sense maintains balance via hair cells in the utricle, the sacral, and semicircular canals that direct head position and gravity. Proprioceptive and kinesthetic systems inform the brain about body position and movement through stretch and tension receptors in muscles, joints, tendons, and the integumentary system, which is the skin. Concerning Gestalt principles of perception, Gestalt theorists have greatly influenced sensation and perception, proposing principles like figure-ground relationship, proximity, similarity, good continuation, and closure in order to explain how sensory information is organized. Perception is not always accurate, and can be influenced by bias, prejudice, and other factors as well. Concerning consciousness or states of consciousness, states of consciousness involve varying levels of awareness of our surroundings and internal states. For example, sleep. Sleep is characterized by different stages, including deep sleep and dreaming, such as REM sleep. Sleep disorders or conditions that disrupt normal sleep patterns, such as insomnia, sleep apnea, and narcolepsy. There are altered states of consciousness that can result from meditation, which can promote relaxation and focus, hypnosis, which heightens suggestibility and can aid in behavior modification. And then, of course, there are psychoactive drugs, which alter brain function, affecting people's moods, perceptions, and behaviors. And so we might want to also talk about insomnia as well. There's common sleep disorders and sleep problems, and insomnia is difficulty falling or staying asleep. Parasomnia is unwanted behaviors during sleep, including RBD, which is REM sleep behavior disorder. Sleepwalking is another parasomnia. Restless leg syndrome and night terrors as well as a part of the parasomnias. Sleep apnea is breathing interruptions during a person's sleep. There is sudden infant death syndrome, SIDS, which is when an infant stops breathing during sleep and it can result in death. Narcolepsy is also a sleep disorder. It can be sudden. You can have irresistible sleep episodes, often with cataplexy and hallucinations as well. Going up some other things as well would be, what is consciousness? Well, states of consciousness and biological rhythms. Circadian rhythms are biological cycles that are regulated by the suprachiasmatic nucleus, the SCN, that align with the day-night cycle. Light is a key factor in maintaining these rhythms. So we need to sleep when it's dark, or keep the windows barred, or something like that. Disruptions. Traveling across time zones or working rotating shifts can also cause circadian disruptions, leading to insomnia, fatigue, and reduced alertness. Bright light therapy is an effective strategy in regulating and realigning disrupted circadian rhythms, and sleep debt is prolonged sleep deprivation, which can cause psychological and physiological issues. Why do we need sleep? Why is it important? Why do we sleep? Well, physical growth is one reason. Sleep triggers the release of hormones essential for growth and maturation. Learning and memory. Research suggests that sleep plays a vital role in consolidating learning and memory. With a good night's sleep and a good brain that has rest, the body is able to repair itself and go into deeper inquiries. It also affects brain function. Complex brain systems regulate different aspects of sleep, highlighting its pertinence for overall well-being. And so the importance of sleep is good. Sleep and why we sleep: for physical growth, learning and memory, and overall brain function. There are certain stages of sleep and their characteristics. Stage 1 of sleep is the transition from wakefulness, with alpha waves shifting to theta waves. Again, alpha being the first letter of the Greek alphabet, theta being one of the other ones. Alpha, beta, gamma, delta, epsilon, zeta, eta, theta. Theta is the 8th letter in the Greek alphabet. Stage 2 of sleep is the appearance of sleep spindles and K complexes. Stage 3 and 4 is called slow wave sleep and is dominated by delta waves. And then REM sleep is rapid eye movements, muscle paralysis, and vivid dreaming during that stage. The role of sleep in learning and memory, both in REM and REM sleep, contribute to memory and consolidation, which means you get more sleep, you'll be able to consolidate your memories better. Dreams, of course, may reflect significant life events, or they might serve as a form of proto-consciousness, which might aid in conscious thought. And of course, some sleep problems and disorders. We've already gone over insomnia, parasomnias, sleep apnea, sudden infant death syndrome, SIDS, and narcolepsy. There is also substance use and substance abuse. Substance use disorder is a compulsive pattern of drug use despite negative consequences, and it involves both physical and psychological dependence. For example, depressants affect GABA. We can have depressants such as alcohol, barbiturates, or benzodiazepines. Stimulants, which affect dopamine levels. Stimulants could be cocaine, amphetamine, and MDMA, for example. Other stimulants could be like nicotine, which affects acetylcholine. Another stimulant is also caffeine, and caffeine also affects adenosine. And opiates. Opiates are powerful pain relievers used in the medical field, and of course they often affect the endogenous opioid system. And then, of course, hallucinations from substance abuse can cause sensory and perceptual changes. They affect various neurotransmitter systems. And then there are some other states of consciousness, like hypnosis. It's a focused state of self-awareness involving suggested changes in behavior and experience. Meditation promotes relaxed yet focused awareness, but both can create altered states of consciousness and have potential therapeutic applications for both physical and psychological disorders. And of course, that'll wrap up sensation and perception, as well as states of consciousness. In the next section, we will talk about learning. What is learning? What's classical condition? What is operant conditioning? What is observational learning or observational modeling? So then we can start to get into our sixth section and talk about learning. And then in our seventh section, we'll talk about thinking and intelligence. What is cognition? What is language? What is problem solving? What is intelligence? What is creativity? What is a measure of intelligence, or how is intelligence quotients measured? And what is the source of intelligence? And then section 8, we'll talk about memory.